All right, hello everybody. Uh, it's the Mad Lad, and today we're going to be looking at making a DIY homing missile. So, this is meant to be as uh, an engineering kind of a channel. So, we'll first start looking at what it might mean to have a, homing missile. First of all, not a real missile in the sense that, it's not meant to be uh, launched at anything like people, tanks, whatever. It's a more of a robotics project rather than, a weaponized system. But in general, you know, what does it mean to have a homing missile? And, as a starting point, uh, I was uh, looking around where I was, specifically looking at, military examples of homing missiles. And one thing that really kind of got my attention is the Javelin missile, right? So, as a robotics project kind of a thing, you have two components on a Javelin missile. You can see here you have, uh, a British soldier here training, and you have your kind of like the HMI or the human machine interface right here, and then you have your missile tube over there, and your missile is a is your robot here, and then this big thing is the your interface that you interact with it. So I wanted to make something like this. Like there's been a few videos on uh, on YouTube where people make guided RC planes. Basically, in reality, anything RC with an FOV is kind of like a guided missile. It's a it's a remotely controlled plane with a camera on it that you can see through. So basically anything like that almost fits the description of a guided missile if it's meant to hit a target. So by definition, a missile is something that's propelled at a target. So, if the intent is to crash something into something and you're in control, then all of a sudden it's a guided missile. But I wanted to have something more like a homing missile, which is, what a javelin missile is. And the basics of the javelin missile is that a person can look through the command unit here, the user interface, select a target, and then push a button and fire the missile, and the missile will then track towards the target on its own. And it's a fire and forget kind of system. So I wanted to make the same thing, but kind of as a robotics project. And instead of a missile, just have a fixed wing drone that can fly. And in the Javelin missile uses infrared seeking to look for its target. However, for uh, for this project, I want to make a project that other people can do or can actually repeat. And, I wanted to keep the project more simple. So in this case, the guidance would be just computer vision with regular, visual spectrum light. Now, why might you want to make a system where you can track a target, uh, and from a moving plane or drone or whatever? There's many use cases. Obviously here we're looking at a use case of a guided missile, but let's say you're trying to land something, like let's say you have a drone that needs to land autonomously and it needs to pick out a place where it can land. Whether it's a drone that's like a quadrotor or it's a drone, a fixed wing drone. So, let's say you're flying a quadrotor and it needs to autonomously land and it needs to find a spot where it can land. So, you can use some computer vision and machine learning to identify a spot in an image. Like, oh, it looks like there's a clearing there in the grass. I can go ahead and try to touch down there. And let's say you're flying, you're actually controlling uh, a fixed wing drone, then it might need to identify, use computer vision and machine learning techniques to identify somewhere where it's not just clear, but the space there's enough space. If you need to land a fixed wing aircraft, you need a landing strip, so you need to have enough room before you run out of runway. So there are other uses for being able to track movement in general. Let's say you have a tracking camera or a tracking spotlight on an aircraft. So really, it's the tracking spotlight is just the tracking camera plus you're pointing a light at wherever the camera is pointing. So uh, let's start by looking at you know what what would we consider, seeing how this is you know a robotics project and it's meant to be repeated by other people. What would be a measure of success, kind of like what is our goal here? So I'm gonna create a new slide here, delete all the stuff, and I've been thinking about it for a while. At first, because my inspiration was the the Javelin missile, I kind of wanted to lock onto a target on the ground and then be able to, just smash into it, and that's it. However, since this is a development project where the odds are you're not going to get it right on the first try, so your airframe is going to take a beating, which means that all of your electronics are also going to take a beating. And, ideally, you want to, if you have, basically a small computer mounted to your airframe and you keep crashing it, eventually the g-forces of the crash are going to break something. It might be some component, where the repeated vibration will break it off. And, you can mitigate vibrations, you can suspend the whole system and, dampen out the vibration. But eventually something will break. So ideally, you actually don't want to crash your pretend missile into anything hard. So I've been thinking, and let's say you want to launch something, and let's see if uh, what kind of images we can get from whatchamacallit, from Google Docs here, if any at all. Shape, nope. Table, image. Do we have anything here? Nope. Camera, nope, nope. Well, this is kind of useless. So for now, let's pretend that our aircraft is this arrow. So, as I said before, we don't want to crash it into the ground. So we definitely don't want it to do that and hit into the ground. Instead, we want it to keep flying, and when it hits the pretend target, you don't actually want it to experience any any high forces or anything like that. So I think I have the solution to that problem, and basically the idea is to use a let's see, to use a balloon to as the target, just like that. So I don't know if you can see it in the thumbnail for the video or not, but there you have the Javelin missile command unit interface, and there we're tracking a balloon. So the general idea is you can have your plane. So let's pretend, oops, not what I meant to do. So this is your plane. It has guidance on it, and you can lock on to a balloon, and maybe you have a metal pokey bit at the end, so that when you hit the balloon it pops. But that's the 30,000 feet overview. So if we look at this, what kind of components do we need at a high level? So we have our plane, right? We might need to have some sort of a launch platform, right? So let me add a couple of more squares here. So we might have a launcher here. Launcher. Please center it. Just like that. All right. So we have a launcher, and similar to the Javelin missile, maybe we want to have some sort of interface, right? So this is our HMI, or user interface. So since these are meant to be easily recreatable components, for a plane, what we could use is a typical I know NRC, they like to make their aircraft out of Dollar Tree foam board. So this is a foam board plane. We have a launcher, which is some structure which can, maybe it launches. It could be as simple as some sort of a ramp that holds the plane before it's ready to, go fly at something. So this could be either a ramp or, an actual propelled launcher. Potentially you could stretch some rubber tubing to kind of make a kind of like a ballistic kind of a thing where you launch your plane from. Finally, what's a user interface? And I think the most convenient interface that you can come up with that's fairly easy to develop for is a web browser based interface, because whatever is doing our guidance, all of that can be encapsulated on the Raspberry Pi or some other single board computer, and you can just host a website over on Wi-Fi, over Wi-Fi. So at a high level, we have three components, plus four, which is the target. But, you have a plane that's sitting on a launcher. You have a user interface which communicates to the plane and potentially also the launcher if it is a propelled launcher. So let me just make this a little bit thicker. Nope, too much. Okay. And maybe add some color to it as well. Red line. All right. So, going back, we have a launcher. On top of it, we have some sort of an autonomous plane. You have a little user interface. The user interface will be able to look at the target from the point of view of the plane, and you'll be able to specify what the target is, and you'll have, probably some sort of a launch button, and then you hit the launch button and off the plane goes. And the order is messed up. Let's see if I can bring this to front. Boom. And eventually the plane hits the balloon pops, and the plane keeps going. So since this is an RC, or since the components here are going to be mainly RC kind of base components for the plane, there's probably going to be one more component here, which is our RC radio. So this is the RC transmitter, which can also talk to the plane. And basically the general idea is that you want to be able to have a manual override for something like this, especially once you've hit the target, the balloon pops. Well, now you have a drone which doesn't know what to do because it tracked to the end of, to the target, and then it kind of completed its mission, but nothing happened. So now it has a lost target and no guidance information. So once the balloon pops, you want to be able to use your transmitter to go ahead and basically go back to manual control and land the plane. So this is DIY homing missile. Do I need to hit save? I guess not. So, this was a very high level overview of the systems. Let's take a closer look at what we would have on the plane to actually make all this work. Right? Let's make a new slide. So this is, I guess, plane systems. So what can we expect to have on our plane? Right, so let me copy this over. So we need to be able to track some sort of a balloon, right? We need to be able to interface with these systems. So we need to be able to interface with these systems as well. So RC transmitter. So we'll actually start pretty easy, or pretty, okay. When there's a camera on you, your IQ drops way, way fast. All right, so since we have a RC transmitter, it's an easy guess that yes, we're going to have an RC receiver in our system diagram for the plane. So the RC receiver is going to talk to RC transmitter, user interface, web browser. So this really is a stand-in for your, let's say this is really your phone at a high level view, and your phone will actually be talking to a computer here, right? So on the plane, there's going to be some sort of a single board computer. And the single board computer will actually handle a lot of functions. One of the functions is to serve up a user interface. Obviously we see here that we have a balloon and we need to interface with that somehow. So obviously we're going to have a camera here. Camera. So we have camera, looks at the balloon, RC receiver talks to the RC transmitter, single board computer serves up the user interface, but the single board computer will also talk to the camera. So let's keep moving. So we have a plane and we need to be able to control it, and there's going to be a couple of components that go into that. So typically, if we start with this plane being an RC plane, we know that we're going to have some servos on it to control the control surfaces on the airplane. Maybe this will be a very simple 3-channel type plane where maybe there's only a rudder and an elevator, or maybe it's an Elevon type of plane. But you're definitely going to have some servos. You're going to have some sort of a motor as well. Alright, so we're going to have a motor on here. All of this requires power, excuse me. So we're going to have some sort of a battery on here. Battery. Now motors can supply enough power to power the servos and RC receivers, or rather, a motor is usually controlled by an ESC. So let me add that component in here. ESC plus UBEC. So ESCs often have UBECs, and BEC stands for battery eliminator circuit. And basically what the UBEC does in a typical RC airplane is it will provide power to your servos and your RC receiver. And typically that's good enough. However, if you have a single board computer, depending on how much, in our case, because we have extra components, extra electrical components on this plane, your single board computer can have a significant amount of power draw. So it might have its own UBEC. So you have your UBEC on the ESC powering your servos and potentially the RC receiver, and then you have your UBEC which powers your single board computer. Let's see, do we have any other high level components on our plane? Yes, we do. We have one more thing. So your single board computer provides high level guidance information, and it provides computer vision for the camera. It serves up a web interface that you can interact with. However, the actual airplane is controlled at any given moment by the flight controller. So the flight controller is a small microcontroller that that actually directs the servos, or it tells the servos what the deflection should be. So now that we kind of got a general idea, well, actually, if we have a flight controller, if we're making our own flight controller, there's going to be a few more components depending on how complex or how good of a flight controller that we want. So over here we would have a IMU, or inertial measurement unit, and your IMU basically gives you access to things like gyroscopes, accelerometers, and magnetometers, which allow you to figure out how your airplane is oriented relative to the world around it. And I think I may want to add a whatchamacallit, an ultrasound altimeter. So I'm just going to call it an altimeter in here, but this is optional. I want it included here just so that I can have a kind of hold altitude mode on the plane, but for the for the homing missile part, it's not really required. So let's reorganize all of these systems and show how they interact with each other. So don't really care about these anymore. I'm going to keep them around for now, but we have our battery, right? And the battery is connected directly to the ESC and this UBEC. So let me move this stuff aside. Oops. Move this back. So we have the battery connected to the ESC and also, oops, and this UBEC. On our, so conveniently, all the sensors here are already kind of in a group here. We have our motor, which is an actuator. We have another actuator here. We have a flight controller, which controls the actuators. We have a single board computer, and we have an RC receiver. So let's do some more organization here. So the flight controller and the SPC. So the UBEC powers the flight controller, and it's going to power the single board computer. So these are power connections. So I'm going to color them, let's say, with green and make them a little bit thicker. So those are power connections. Let's see, the ESC here. I think the way I had it set up before when I was playing around with the electronics, I think I also had the UBEC powering the flight controller, also powering the RC receiver as well. So let me add that in here as well. So we have RC receiver here. The RC receiver is going to talk to the flight controller, and it's going to send data to it. So this is a data connection, so I'm going to color it blue, make it a little bit thicker. So there's also going to be data connections from the flight controller to the SBC, the single board computer. There's going to be a data connection from flight controller to the ESC so that it can control that. There's going to be a data connection to the servos. So I guess there's a connection here, and it's kind of a power connection. So I'm going to once again color it as green. Since the ESC will power the motor and the flight controller will control the ESC, we also have a data connection to the IMU. We have a data connection here to the altimeter, and we have a data connection from the single board computer to the camera. So I think that kind of sums it up. So let me grab all these lines. Let me recolor them again, give them a little more thickness, and I think that about sums it up. So I'm going to move this single board computer node. So this is also data connections. Let's make them blue, give them a little more thickness. Let me reconnect this over here, connect this over here. IMU, servos, motor, let me recolor some of these nodes. So motors, servos are actuators. I'm gonna decide that they're gonna be yellowish. We have sensors, altimeter, IMU, camera. Let's make those light blue. We have computers. Let's make them light green. I guess this is kind of a computer, so I'm also going to make it light green. And we have kind of power units here. I'm going to make them light red. So at a high level, this is our system, right? We have a battery. It powers the ESC and the UBEC, or ESC UBEC combination and the dedicated UBEC. The ESC is also powering the motor. Let's see, the dedicated UBEC is powering the RC receiver, the flight controller, the single board computer, and let's see, moving out from there, the RC receiver talks to the RC transmitter, and it also provides information to the flight controller as to what to do. The flight controller controls the servos, and through the ESC it controls the motor. The flight controller can talk to the single board computer, so it can get guidance information from there. The flight controller also monitors the IMU and the altimeter so that it can have controlled flight, or so that it can have stabilized flight and controlled flight. And we have the single board computer that talks to the camera. Basically the single board computer is going to serve up our user interface, and it's also gonna do the computer vision logic to track the target. So I think that's gonna sum it up for now. And I think I'm gonna end part one right here. This has already been over half an hour of me trying to get my mind wrapped around this. So I think that's good enough for now. So thank you for watching, and stay tuned for more episodes on this homing missile robotics project. All right, thank you, and take care.